Hey guys, today we're going to learn about how to simplify rational exponents. But before we do a couple examples and talk about the exponent rules, let's talk about what's the point. Why do we simplify rational exponents? Well, exponents give you a way to generalize repeated multiplication and division. And the key word there is generalize. And then these operations are used very often in a lot of real-world applications. For example, the energy of a source, for example sound, decreases exponentially from its distance. And that relationship can be modeled by a negative exponent. So these are very frequent applications in real life. And in order to simplify exponents, there are 7 pretty straightforward rules that you can follow. And so what we're going to do is go over a couple examples that apply these rules to simplifying exponents. So the first example we're going to do is x to the third divided by x to the third. And this example is going to answer the question, why is anything to the 0 power always 1? Well, you'll see using the exponent rules why that's true. So let's start by applying one of these rules, and we're going to use the quotient rule here, which says that something with the same base, a to an exponent divided by a to a different exponent, is equal to that base to the exponents being subtracted. So we can apply this here by saying that x to the third over x to the third is equal to the x to the 3 minus 3, which is x to the 0, which ties into another exponent rule, which is the 0 exponent. A to the 0 is 1, or x to the 0 is 1. So any base to the 0 exponent is 1. Another way to kind of think about this, well, what's x to the third? It's just like saying x times x times x 3 times over, again, x to the third. And so if we had something like 5 over 5, well, at this point in your education, you probably know something over the same thing as 1. They cancel out, and that's the identity property. So these x's cancel out, these x's cancel out, these x's cancel out. What do you have left? You have x, but you don't have any of them. So kind of like the same idea with 5 over 5 being 1. If they all cancel out, that's the identity property, and that's 1. So that ties in your negative exponent rules to this idea of canceling out. Let's do another example, applying a couple more of these rules. The second example we're going to do is going to be x to the negative third, y to the 1/2, and we'll take that to the 1/3 powered. And so there's a couple things going on here, and we're going to work from the outside in, which means we're going to start with that 1/3, and that's going to be your power rule, which says that some exponent, some base to an exponent multiplied by another exponent, as you see here, is equal to that base, and then the exponents get multiplied. That's called the power rule. So let's apply that first. So it's going to be x to the negative third times 1/3, negative 3 times 1/3. Move it over here. Is going to be x to the negative 3 over 3, because negative 3 times 1/3 is negative 3/3. And then 1/2 times 1/3 is going to be 1/6. So after applying the power rule, we're left with this. Now let's clean up this negative 3 over 3. We'll just simplify that fraction down a bit. That's x to the negative 1 to the 1/6. And now we can apply another one of the power rules. And the power rule we're going to apply is the negative exponent. So anything a base to a negative exponent is equal to 1 over that same base to the positive exponent. So in this case, we're going to apply the negative exponent rule to just the x. So it's going to become 1 over x. And then let's rewrite the 1 over 6. Now let's look at that 1 over 6. This is going to apply to the 1/6, we're going to apply the fractional exponent, which says that a base to x over y is equal to the root, the y root, the bottom, the denominator becomes the index of your radical, and then the base is raised to the power of your numerator. So in this case, the base is going to be 6th. So we can simplify this down. I'm going to rewrite 1 over x times the 6th root, of y. And then finally, to combine these together, we're going to get the 6th root of y over x. And that is your simplified answer to what we started with. One more example. And in this last example, we're going to do x to the negative 2/3 times x to the 1/3 over x to the 3rd. So let's start by applying the product rule here. The product rule says that if you're multiplying two exponents with the same base but a different power, it's the same thing as adding them together. So let's apply that product rule in the next step, which is going to be x to the negative 2/3 plus 1/3, and then we'll keep that over x to the 3rd, and we'll simplify that. X to the negative 2/3 plus 1/3, since they have the same denominator, we can just add the numerators. If they had a different denominator, we'd first get a common denominator. But in this case, it's going to be x to the negative 1/3 over x to the 3rd. So at this point, we're going to apply the quotient rule. The quotient rule says that if you're dividing, similar to the product rule, if you're dividing, you end up subtracting your exponents, your powers, as long as they have the same base. So we have x to the negative 1/3 that's divided by x to the 3rd. So in this next step, we're going to apply the quotient rule. So you have x to the negative 1/3 minus 3. And now, since negative 1/3 and minus 3 are not the same denominators, we got to get a common denominator. So in this case, we can rewrite it as x to the negative 1/3. Since I want the denominator to be 3, I can subtract 9 over 3. 9 over 3 is the same thing as 3, but now they have a common denominator, which lets me subtract. So I have x to the negative 1 minus 9, which is going to be negative 10 over 3. And now let's apply, since I have a negative exponent, I'm going to apply the negative exponent rule to make this x1 over x to the 10 over 3. And then to finish it off, we're going to use the fractional exponent. So we're going to apply this rule to write it as 1 over My denominator becomes the index of my radical, so it's going to be a cube root of x, and the numerator becomes the exponent, so 1 over x to the 10th. And now that one is simplified. So starting with this form, we end up with a simplified version of that, which is 1 over cube root of x to the 10th. So again, it's just a matter of applying the exponent rules in order to break down a problem into its simplest form. Thanks for watching.